This is my first video about the Haxe programming language. I decided to begin by sharing a bit of my history with it, but feel free to skip to this timestamp where I discuss the language itself and the specific features I like and use. So how did it all start? Between the late 2000s and early 2010s, I worked a lot with Adobe Flash and Air platforms. I developed some graphical interfaces for educational software and things of this nature. I also was trying my best to create the next Flash game hit that would bring me millions and fame. The latter didn't quite work out, unfortunately. I quite enjoyed programming with ActionScript 3, the language used to program for these platforms. It was a great language in my opinion. It was an implementation of ECMAScript, so in a sense it was a cousin of JavaScript. But JavaScript at the time was terrible. Okay, I know a lot of you will say that JavaScript is still terrible, but let's at least agree that it is better now than it was 15 years ago. Back then, in ActionScript 3, you could use features unheard of in JavaScript, such as modules, full-fledged object-oriented programming, and types. TypeScript didn't exist yet, so it was a completely different level of programming experience compared to JavaScript. But as we all know, eventually Flash died. Browser games became less popular as everyone switched to smartphones for casual gaming. Unity and Steam became huge, so a lot of former Flash game developers got new tools and outlets. But even long before the time of death was officially declared, which by the way only happened in 2020, people started prophesying the imminent demise of the platform. It all probably started with the fact that Apple did not include Flash support in the iOS Safari when the first iPhone came out. So naturally developers started to look for alternatives, myself included. I tried many different things. At some point I was so desperate that I used Java for a while. Unity wasn't an option for me as by that time I had already switched to Linux and macOS for development, and I didn't want to go back to Windows. One project I stumbled upon that seemingly checked all the boxes was OpenFL, a framework positioning itself as open source alternative to Flash and Air. It also allowed building native applications for desktop and mobile from the same codebase. So I started using OpenFL for all my hobby projects. The more I used it, the more I fell in love with the programming language used in the framework, the Haxe programming language. The language shares some similarities with ActionScript 3, so there is also a nostalgic component to it. It's 2024 now, and Haxe is still one of my favorite programming languages. I use it for all my hobby projects such as the game engine I'm working on, and I always try to find opportunities to use it whenever possible. And before even delving into the language itself, it's important to talk about the awesomeness of the compiler. Its killer feature is its ability to take Haxe code and generate code in another programming language. It supports a wide range of languages such as Java, JavaScript, PHP, C#, C++, Python, Lua, and it can even produce bytecode for JVM and Flash. I hope you see the possibilities it opens. Now let me tell you about some of the language features I find particularly appealing. Type system. For one, it exists. Since Haxe can be transpiled to dynamically typed languages such as JavaScript and Python, it enables writing type-safe code for platforms supported by these languages. It can be used as an alternative to TypeScript, for example. Standard library. The Haxe standard library is incredibly rich. It provides things like string manipulation, data structures, parsing and serialization for JSON and XML, utilities for standard I/O, file operations, networking, and more. Enums and pattern matching. Pattern matching and enums are incredibly powerful features in Haxe. If you are familiar with the Rust programming language, then you already know what I'm talking about. Pattern matching in Haxe is implemented in a very similar manner. The switch expression in Haxe works differently from that of C-like programming languages. It can be used similarly in very basic scenario, but one important difference here is that cases never fall through, so you don't need to put the break statement after each one. You can match arrays and structures using this statement. You can use the OR operator or even the if statement in patterns. However, the switch statement is most powerful when it comes to matching enums. Enums in Haxe can have data associated with each variant. This allows for many powerful techniques and design patterns. Abstract. Don't confuse this with abstract class, which Haxe also has. Abstract allow you to create a new type by wrapping existing one and adding extra functionality to it. You can define new methods and even operators for existing types. Static extension. If you define a static method within a class, and the first argument of this method has a specific type, you can utilize the using keyword to import this class, and the method will be accessible as if it was defined within the type. Any static class method with at least one argument can be used as a static extension. Macros. Last but not least are macros. This feature is so powerful that I won't even try to explain it in detail right now. In short, a macro is a part of your program's code that's executed by the compiler during compile time. It can be used to simply execute some logic only in compile time, but also macros can generate and alter the code of your program. And of course, macros open up a whole new world of metaprogramming. And remember, you can use this power while targeting platforms that don't have these abilities natively. These are just some features that I find most useful in my projects. If you want to learn more, I recommend taking a look at the official documentation. Additionally, I encourage you to try Haxe yourself. And that's it for this video. Thank you for watching. Bye!